Welcome to today's Explainer. Today, we're exploring an absolute marvel of engineering, your own body. We're stepping inside the fascinating biological factory that literally powers human life. So, let's dive right in.
Imagine taking a big bite out of your favorite sandwich. It's a pretty simple, everyday action, right? But that single bite triggers an incredibly complex journey. How exactly does a physical, everyday object like a sandwich completely transform into the vital nutrients, energy, and microscopic building blocks your body absolutely needs? Seriously, how does that sandwich essentially become you? Well, let's map out the exact mechanics.
Here's our roadmap for today. We'll start with the sandwich journey begins, move into physical versus chemical digestion, break down the anatomy of the breakdown, look at pushing food with peristalsis, and wrap up with common mistakes and a quick recap. Mastering this step-by-step flowchart is absolutely crucial if you're tackling O-level biology exams, but honestly, it's also just the baseline for understanding how we survive.
Okay, Section 1. The sandwich journey begins. Let's establish the absolute core goal of your digestive system. Digestion is, quite simply, the systemic process of breaking down complex food into simpler, absorbable units. If you track the journey from the full sandwich over on the left, watch how it gets completely dismantled into those microscopic molecules on the right. Your body literally can't use a piece of bread as it is. It has to break it down into fundamental building blocks like glucose, amino acids, and fatty acids. These are the specific units tiny enough to actually get absorbed directly into your bloodstream.
Right, on to Section 2, physical versus chemical digestion. To achieve this massive breakdown, your body actually uses two fundamentally different forces.
Let's contrast these parallel processes side by side here. On the left, we've got physical digestion. Think of this just like tearing a piece of paper. It represents the physical chewing and churning. As you can see, this dramatically increases the surface area of the food, but it makes absolutely no change to the chemical structure itself. Now contrast that with chemical digestion on the right. If we zoom into the molecular level right here, we see enzymes acting as biological catalysts. They are actively snapping and breaking those chemical bonds apart. So physical creates surface area, while chemical does the actual microscopic dismantling.
Moving to Section 3, anatomy of the breakdown. Where exactly do these physical and chemical rules actually take place?
When mapping out the human digestive system, you've got to recognize two distinct physical components. On the left, highlighted by that glowing pathway, is the alimentary canal. This is the main continuous transit tube running all the way from your mouth down to the anus. But on the right, we have the accessory organs, the salivary glands, the liver, and the pancreas. Now, they sit completely outside that main transit tube, but notice those visual pointers? See how they inject and secrete crucial digestive juices directly into the canal? That's what keeps the whole breakdown process firing.
Let's track this macro journey as a chronological flowchart. Step 1 kicks off in the mouth, where physical chewing instantly and dramatically increases the food's surface area. Then, following the path down to Step 2, the food arrives right here in the stomach. Inside, the thick muscular walls actively churn, physically squeezing and mixing everything to continue that massive mechanical breakdown.
Okay, now let's overlay the chemical rules onto those exact same organs. This is your definitive chemical cheat sheet, so pay close attention to how these variables map out. Up in the mouth, the specific enzyme at work is salivary amylase. Its target input is starch, which it breaks down to output maltose. But as we move down to the stomach, the environment completely changes. The enzyme down here is pepsin, which relies on a highly acidic environment, specifically hydrochloric acid, to even function. Pepsin explicitly targets proteins, actively snapping those bonds to output polypeptides. Visualizing these exact inputs and outputs is absolutely key to mastering this process.
All right, Section 4, pushing food through peristalsis. Because, let's be real, how does food actually travel from the mouth down to the stomach? It definitely doesn't just fall via gravity.
Your body relies on a highly specific mechanical action called peristalsis. Simply put, this is a rhythmic, wave-like muscle contraction right in the esophagus. Notice the downward directional arrows here. See how the muscles literally contract behind the ball of food, which we formally call the bolus, effectively squeezing it and pushing it downward. It's a continuous, dynamic flow. It's kind of like squeezing a brand new tube of toothpaste from the top down to force the contents exactly where they need to go.
Finally, Section 5, common mistakes and recap. Let's tackle exactly where students tend to lose major points on exams.
We need to completely separate reality from a very common misconception.
The big mistake on the right is assuming that actual chemical digestion occurs inside the esophagus simply because food spends time traveling through it. But look at the reality over on the left. The esophagus has exactly one job. It simply moves food to the stomach via peristalsis. Absolutely zero chemical digestion happens here. It is quite literally just a transit highway.
Okay, let's do a rapid-fire review to lock all these mechanics in. First up, the core goal of digestion is to dismantle food into micro-absorbable units. Second, physical digestion tears and churns to maximize surface area. Third, chemical digestion deploys those tiny enzymes to snap the chemical bonds. Fourth, this entire factory is a partnership between the main alimentary canal and the juice-secreting accessory organs. And fifth, peristalsis is the mechanical wave actively pushing everything downward.
To wrap things up, I want to leave you with a crucial, slightly provocative study tip. Remember how we just saw pepsin needing hydrochloric acid to work? Well, that reveals a really fascinating dynamic. Different enzymes require completely different pH levels to survive and function. The varying acidic and alkaline environments across your digestive tract actually act as invisible triggers controlling this entire factory. So, if the stomach relies on intense acid, what hidden triggers might the rest of your organs be using? Thanks so much for exploring with us today, and keep questioning how your incredible biological machinery actually works.